All right, this question. Now, we've got the timer up. Probably someone maybe get their stopwatch. But first of all, we can deal in Cartesian if we want. But the problem is, once you're looking at z to the power of 4, it becomes a little bit tedious. This is, I believe this was an exam 2 question, but it should be, or could be an exam 1 question. It's a pretty straightforward one. But what we're going to say is that z plus z is equal to, and we could just do this in the corner of our working, just like on the sheet here. I'm going to say that that's root 2 cis of pi on 4. The reason I've converted that polar, to polar is that now we know that we can do root 2 cis pi on 4. Z squared, therefore, using Demoivres' theorem, is root 2 squared is 2 cis of pi on 4 times 2. It's pi on 2, isn't it? And z to the power of 4 is equal to root 2 to the power of 4. Cis of pi on 4 times 4 is just pi. Okay? Now what is root 2 to the power of 4?
2 squared, which is 4.
2 squared, which is 4 cis pi of pi. So the question's worth 1 mark of each. Each one of these is worth 1 mark. So we've got to plot z squared. So z has a modulus of root 2. Now you've got to understand that root 2 is somewhere between that and it's an angle of pi on 4. So I'm going to say that maybe around about sort of, where do you think? Maybe here? Is that okay? Yep. All right, and then all you have to do is just mark that and then just say that that's Z there. You'll get your mark for that, yes. Ah, that's correct. Okay, yeah, you're right. Okay, that's a very good point. Thank you. I still would have got the mark, but if I was a little bit too far to the right, I reckon you would have lost it. The next thing is z squared. Well, z squared is 2 cis of pi on 2, which means that it's a modulus of 2, so it's going to be on the circle, and it's going to be 2 cis of pi on 2 is just here, is it not? Yep. And that is z squared. And finally, z to the power of 4 is 4 cis of pi, which means we're going around here. 4 cis of pi is also negative 4 what? Just negative 4. Negative 4. So therefore, there's z to the power of 4. Okay? That should probably take you about 2 minutes. And you've got 4.5 minutes in an exam. Now what I'm going to do is I'm going to show you the next problem we're going to do. Because today this video is going to be about applying Demoivres' theorem. This is from exam 2. Now, this all looks really ugly. But if we have a look, it's worth 3 marks, and this isn't from exam 2, so you can use a calculator if you wish, but the problem is you have 3 marks, which means that an answer is only worth 1 mark. There is a method mark. So you really want to show what your method is. Show that you're using Demoivres' theorem. So what we're going to do is I'm going to pause this video, and I'm going to give you 4 minutes, which is just a slight bit under, because it should be done in about 4 minutes, tops. Have a go at this question, please. I'm going to pause the video now. Okay, so with this one, first of all, I'm going to show you just the minimal amount of working required to get your 3 marks. Now, first of all, we're saying that z cubed is equal to 200 to the power of a half cis of minus 3 pi on 4. Now, what you really need to consider is that when we're finding the roots, that we're actually going to be 3 solutions to this equation. If we're taking the third root of z cubed, there's going to be 3 solutions equally spaced on an Argand diagram. If there's going to be 8 roots, there's going to be 8. If it's to the power of 8, there's going to be 8 roots, and they're going to be equally spaced, 45 degrees apart. So what we've got to do is to take this into account that we can then add. I'm going to add 2k pi such that k is an element of integers. Is that z? Thank you. Okay. All right. Now, what we're going to do now is we're going to say that z is equal to 200 to the power of a half cis, if you like. I'm going to do like square brackets, cis of minus 3 pi on 4 plus 2k pi to the power of 1/3. And now we can, I'm going to even be smart and I'm going to say Demoivres. They love it, examiners, when you say that. You know what rule you're using in things, but you don't need to. But you know, that's just, they love it. They love it. They might find you a mark somewhere. Okay, now what we're going to do is apply Demoivres. 200 to the power of a half times a third is 200 to the power of 1/6. Do we agree with that? Cis of... now what we're going to do is we're going to multiply that by a third, don't we? So what it is, isn't it a third? Negative 3 pi on 4 plus 2k pi. Are we okay with that? Yes? Okay, now let's apply that. Now that's going to be minus pi on 4, 200 1/6 to the power of 1/6, cis of minus pi on 4. And then I've got a third plus 2k pi on 3. Are we agree with that? How many roots are we going to have? We're going to have 3. So now what we're going to say is, so therefore we can say that z is equal to, find all the distinct complex numbers z, such as z cubed is equal to this. We're going to say that z is equal to 200 1/6 cis of negative pi on 4, because that it means, what's that for? That's for k is equal to 0. What about if I add, if k is equal to 1? Is that going to be within my argument? 2 pi on 3, so that's like 120 degrees, subtract 45 degrees. That's going to be, yeah? So, and then we're going to say, we don't have to say for k is equal to 1 as well, but what we can do is we can basically just state the answer. But I'm just showing you guys that we need to try in different values, because what's the important thing? You wouldn't write this in an exam, but arg of z is in between negative pi to pi, yes? Okay, so what we need to do is, I'm going to get rid of that, but you guys need to know that, and it's even on your formula sheet, isn't it? So, for k is equal to 1, z is equal to 200 to the power of 1/6 cis of negative pi on 4 plus 2 pi on 3. What's that, Luke? What is it? 5 pi on 12. Be careful with your fractions. If you need to work fractions out, do it in the corner. It's not going to hurt you. And also is equal to 200 to the power of 6 cis of, what's the other one? Now, they've got to be equally spaced. So what's 5 pi on 12, or what's minus pi on 4? What is 120 degrees the other way? What's that? Negative 11 pi on 12. Now, we've got to ask ourselves the question. Give your answers in the form of that, where, so therefore B is actually, so we don't have to state what A, B and C are because they're different. All right? So my answers are that. Now I guess what I want to do is just make sure, have we answered, is that what, would that give us full marks? Why?
Well, you need to set it up.
Okay. Well, A is 200, isn't it? And N is... Yeah, that's fine.
No, like I was just saying, like, you can't say Z equals and then equals.
Yeah, no. What we've got to do is we've got to actually have commas between each of these. Okay? Because you can't... These aren't equal. So I wanted to make that mistake to show you guys that this isn't right. What we have to say is that we have to list each of these as 3 solutions. Did you have a question, Lockie? Just 1 sec, I'm going to come over so you can ask the question.
This may be a dumb question, but why is it 5 pi on 12?
5 pi on 12 because for k is equal to 1, 2 pi on 3, 2 pi on 3, and we can do it in the corner, 2 pi on 3 minus pi on 4. Common denominator of 12.
That one's times 3.
That's right. So it's 8 pi on 12 minus 3 pi on 12. Does that make sense?
Yeah.
Okay. So thank you, Lockie. That's a good. But that's the thing we want. So that's it. And another thing is though, if you think that you've got your calculator, So you don't have to do these things. If this was a calculator, you could just add, you could add 120 degrees to that, and the calculator will tell you in radians what it is. All right, but I did it by hand. Okay, and you could easily do it by hand. Now I'm going to pause this video, and where was this exam question? This was, I don't know, where was it from? I'm not sure which exam it was from. 2010 exam 2. Let's see how well it was done. Okay, considering you have a calculator, and I'll show you later. And I'm just going to show, here you go, students. You can see it here, our answer's correct. All right, now what I'm going to do is I'm going to pause this video and get you to... Okay, so you should have had a go at this. This is one of those questions that you probably don't have to do this much working. You could go straight from, you could write Z is equal to cis of pi on 6. That could be your first line of working. Now Luke's shown all his working, that's fine. That's fine. He's methodical, that's fine. He's not running out of time. You can then go straight from that to Z cubed is equal to cis of pi on 6 cubed, which is equal to cis of pi on 2, which is equal to I. What are we doing? As required. Does it make sense? So really, we could do this amount of working, okay? But there's no harm in doing a little bit extra as long as you're getting it right, okay? Now, so that's worth 1 mark. Now it's saying plot the 3 roots of I on the Argand diagram. Now, what is I? What is plot the 3 roots of I? Now, I, didn't we have Z cubed is equal to what? Is equal to I. So now that's worth 2 marks. I'm going to pause this video. I'm going to get you to have a go at doing that. Remember, what do the 3 roots have to be? Equally spaced. Have we found one of the roots? Yep. Yes, we have. What is that root? Good. And root 3 on 2, what is the modulus of root 3 on 2 plus? The modulus is 1. So therefore, now what's the reference angle for root 3 on 2? Pi on 6, which is 30 degrees. So therefore, that is one of the roots. Do you agree with that? Now the other 3 have to be what? Equally spaced by what? 120 degrees. That's 30. Isn't that 120? There? Is that 120? 90 plus 30? So therefore, the other root is here. Do you agree? And then we've got 90, 130. Would you agree it's there? Yep. There you go. That's worth 2 marks. That's all you have to do. Pretty simple, yeah? Yep. Okay. Now what I'm going to do is I'm going to get you guys... Now we're going to get to regions next time. All right? But what I'm going to get you to do is regions. A lot of stuff in regions. None of that. We've done that last time. There we go. This is this stupid show that questions which are only worth 1 mark, which means there's not that much involved. Then we've got to do this question here worth 2 marks. Looks ugly. Now, can I tell you this, first of all? Are our roots going to come in conjugate pairs? No. Why not? Just one sec. Why aren't they going to come in conjugate pairs?
Because there's non-real coefficients.
Absolutely. Thank you. I'm going to pause the video now, and I'm going to give you 3... Okay, shh. Now, we had a bit of an issue there, shh. But doing the working to verify one solution... We've actually found the other 2. So that means the next 2 marks are fairly straightforward. We can say C above, refer to the above working. The other solutions are Z equals plus or minus 2I. Okay? Now, the last question is, I'd like you to have a go at this one. All right? All right, so for this one... Oh my God. Yes, it's back here. All right, so for... Nah, it's just packed itself. All right, I'm going to stop this video because my thing's decided to pack itself.